Good morning. This is the final presentation for project on evaluation of partial depth pavement repairs on routes heavily traveled by Amish horse and buggies. My name is Munir Nazal. I'm a professor at University of Cincinnati. I would like first to acknowledge my collaborators in this project, Dr. Sangsu Kim from Ohio University, Dr. Ala Abbas from University of Akron, Dr. Mandy Lopez from Louisiana State University. I would like to thank ODOT, RL, and FHWA for sponsoring this study. I would like to thank Ohio Amish Steering Committee and Ohio Amish Safety Committee for helping us through that project. Special thanks to two of the farriers, the Amish farriers that helped us, Chris Miller and Aiden Yoder. I would like also to thank all of the technical liaisons that helped us a lot in this project, and also uh, Jill and Vicky for all their assistance and help throughout this project. Um, this is the outline for my presentation. A little bit of a brief background and going into the objectives. And then basically I will be talking about phase one, what we have done and what we found in phase one, and then going to phase two. And finally, we will go with the conclusions and recommendations and questions and discussion. So, ODOT performs routine repairs on roadways in Ohio to maintain comfortable and safe travel of the public. But roads in Ohio with Amish buggy traffic, they see more frequent repairs as compared to those without any Amish buggy traffic. One of the reasons that people think that this damage and reoccurring basically repairs is really the calks and or the cleat-like welds that typically are welded to the horseshoes that are used to pull those buggies. So those are basically the calks that I'm talking about. Those are used typically to provide adequate traction, and basically they cause a lot of damage to the pavements, which require frequent repairs. So as a result, this project was initiated to solve this problem, basically to develop a longer lasting repairs for roadways in Ohio, specifically those with high Amish buggy traffic, and also to look into changes to the horseshoes that can be made so that to reduce basically the Amish buggy damage to the roadways. And basically, this also another objective was really to evaluate of the cost effectiveness and the cost benefits of the different alternatives proposed in this study. So we had two phases in this project. Phase one, we had basically looked into the problem and tried to identify some solution. And basically, this is the overview of phase one. Started by looking at what is the current practices for ODOT for performing partial depth repair, specifically those on heavy those with heavy Amish buggy traffic. We did looked into literature review to look into alternatives and solutions that have been proposed in other studies, and then we looked into also evaluating the cost that is encountered on roads with and without Amish buggies. And then basically based on that we looked into several solutions, proposed several solutions to resolve the issue and basically reduce the damage caused by the Amish routes to the roads, state routes, as well as local roads in Ohio. Um, So what we found, from our initial analysis in phase one, is that looking at the Amish buggy routes, we found that there is a lot of damage that occurred sometimes a few months after construction. And basically, we have seen a lot of wear, abrasion wear and rutting accumulating during the first year, and basically causing failures within a year or two, and sometimes less than a year. Basically, some of those Amish buggy routes needed considerable repairs. Now, one of the reasons, and I mentioned before, is those calks, the cleats. Those basically cause a lot of abrasion and wearing, and also the problem with those calks are they tend to reduce the contact area, and basically increase the stress intensity, and that's basically what you see here within the top 2 inches. With the stress preliminary stress analysis that we have done, is that we are seeing that those calcs will cause very high stress intensity within almost the top 2 inches, which is basically the surface course of of the pavement and of those routes. And the cores that we obtained from those routes, we found out that there was signs of cracking within the aggregates in the surface course. Now, when we looked into the cost, we found out that comparing the cost for 10 years for routes, several routes, state routes, as well as routes on the local system, or basically local roads with Amish buggy or with heavy Amish buggy traffic and without, we have seen that there was a significant cost difference. There was once there was a heavy Amish buggy traffic, the cost of repairs increased by more than 3 times, and basically that cost was significant, whether it was for ODOT, all the local public agencies in different parts of Ohio. So the conclusions that we had from phase one, it's basically the main de-stresses that we found was really the abrasion and rutting, and mainly caused by those calcs on the horseshoes, mainly because they're increasing the stress intensity on the pavements. The life cycle cost analysis, we have seen that Amish buggy routes, the cost for repairs on Amish buggy routes were at least 3 times more than routes without any Amish buggy traffic. We have proposed several alternatives. Basically, we have proposed mixtures that use a different mix design, a different aggregate structure, different aggregate type, and also asphalt binder to be used in conducting the partial depth repair on Amish buggy routes. A very important thing that we noticed is that there was a proper compaction was not achieved during basically construction of a part or installing partial depth repair and basically performing partial depth repair, and this applies for different routes, whether it is with Amish or without Amish. But basically, this is a very important thing for the Amish buggy routes, because if you have a loose mix, then the rutting will be more significant, and therefore we suggested using a steel, a rotary steel roller compactor should be used, which in some cases it was not. Again, when ODOT was performing those partial depth repair in house. A very important thing is that the alternative mixes that we propose seems to be cost effective, but again we had to verify that in phase two. And very important also was that the alternative horseshoes that should be used basically will result in larger contact area, and basically this will help to reduce the stresses and reduce the damage on the Amish buggy routes. Very we had initially in phase one, we knew that whatever alternatives specifically for the horseshoes, it should be acceptable to the Amish community, and therefore we had meetings with the Amish community starting from phase one, and basically we provided them with the alternatives, and they were very receptive to those alternatives. The only thing that they told us that those alternatives, you need to prove to us that they are cost effective, safe, and not rejected by the horse, so that those can be used in the future. So this led to basically phase two. And in phase two, we had basically, I would say, two important parts. The first part was really designing the asphalt mixture with better rutting and damage resistance. This was done through a lab study and then through a field. And then the other thing was looking into those alternative horseshoes, identifying those alternative horseshoes, and try to see how much the damage will be reduced by using those shoes to the roads, as well as their impact on the horses, and looked into their cost effectiveness, and then basically made recommendation about what alternatives to be used and what type of mixes should be used, and that was for phase two. So I would start with the first part, which is the design and evaluation of new asphalt mixtures for partial depth repairs used on routes with heavy Amish buggy traffic. We looked into different really mixes. We looked into using different types of aggregate. We thought the main thing was also the mix design. We looked into airport mix design and basically airport mixtures, mainly because those mixtures are subjected to high stresses. But we looked also into modifying the aggregate structure based on Bailey's method. And we looked into polymer modified, what they refer to as HIMA, or highly polymer modified, meeting PG 88 minus 22. So we looked at those different mixtures, and basically we also looked at using ground tire rubber or GTR binder, modified binder, to see how that affects the performance. And we compared all that to basically to a control mix, which is the mix that is typically used in Holmes County, the main county that where that project started, and is specifically used on Amish buggy routes. So this is the comprehensive lab testing program that we conducted. Again, we did a lot of testing on the rutting. We used two different tests. We looked also on durability. And basically based on that, we ranked the mixtures and we went with the top three mixes to the field. And basically this is what you can see. Here is the AP. This is the airport mixture that was not modified, and then basically those are the ones that we modified it based on the Bailey's method. The Bailey's method, what it does is really increase the packing within the aggregate structure, and that helps in improving rutting performance and the damage resistance of the asphalt mixture. And you know, this is in here, those are results of the flow number test. The flow number, it's basically that number, the higher the number, it means that we have a higher resistance to rutting. And you can see that those three mixtures, the AP2 mixture, the one with a modified aggregate structure, the airport mixture with a modified aggregate structure based on Bailey's, with the PG76 minus 22, PG88 minus 22, as well as the GTR, they had very good performance, and they were much better than the other mixes, specifically the control mix that we see here. So we went with those mixes in the field. Two of those mixes were used, which is the AP2 76 minus 22 and AP2 88 minus 22. Were used on state routes, state route 241 on the Amish Buggy Routes, and basically those are the routes. Those are about maybe about little bit. It's about 3.5 to 4 feet in width, and basically the mixtures were produced with in an asphalt plant, but all the construction and compaction and monitoring was done by ODOT, so everything was done in a house. We monitored everything, and we monitored compaction, and basically those are pictures of that. Also, Holmes County, they constructed a section. Basically, it's about a mile and a half on a Holmes County Road 114. They had in one lane they had the typical mix, and in another lane they used that AP2 GTR mix. Those are pictures during construction, and again, this is a full lane, so the entire pavement, it was a resurfacing project, so the entire pavement was resurfaced, and you can see here pictures of that. You can see pictures here during the evaluation. Basically, we monitored the performance for about 20 months, and through that we have found that basically the AP2 PG76 minus 22, the PG8 minus 22, that were basically mixes those that were used in construction of and on I mean the partial depth repairs on the Amish routes on State Route 241. They those sections and mixes we had much better performance as compared to the control section. There was rutting development and a lot of reveling here, while there was not much here, although in those sections the main lanes basically had a lot of damage, but that damage stopped at basically at the sections or repaired sections, and basically the cracks stopped there. So specifically the 88 minus 22 had 22 had a significant resistance to cracking. So the next part was the looking into identification and evaluation of different alternative horseshoes. So we had several meetings with the Amish because, as I said, we wanted to make sure that whatever alternatives we identify and we recommend and evaluate, basically those should be acceptable by the Amish. So we have worked with the Amish steering committee. We had several meetings with them, and then basically with designated farriers from the Amish community that basically the Amish steering committee have that they have identified, and we based on that, and based on that discussions and meetings, we have came up with three things that we can do. The first is really changing the calc design. The other thing was using a different method to applying basically to coating the material, the horseshoes, so that enough traction is provided. And then the other one was using an entirely alternative horseshoe that we have. So the changes we looked into with talking with the Amish farriers. We have found that some of the Amish farriers actually use a calc design where the calcs is spread around and basically on a larger area, and they are not tipped, and they do not have a high profile. They are a low profile calc, and basically this we found like that can increase the contact area with the road, and this can reduce significantly the stresses on the roads. And basically this is what we're talking about. This is the current design. You can see that those are tipped and very basically narrow at the tip, And then the other important thing is that they have a high profile, and their area in general to start with is smaller. This is more rounded at the tip, and basically very important, they are spread, so this can reduce significantly the can reduce significantly the stresses, or at least that's what we thought. Also, they mentioned that the Amish farriers mentioned that when using those calcs, their horses actually live longer, and this is something that we used in our analysis, as I will talk about later. A very important thing is that we explored coating the horseshoes with the material to provide enough traction. We went with several alternatives, and basically the alternatives that gave us the best result, where we have a good traction and good wearing resistance. Basically, we had a method. It's basically you applying a tungsten carbide through heating, and basically this was cost effective method, as well as it provided the needed traction, and it had a good resistance to wearing. And again, we explored different grades that you can see, and the grade 24 was the one that we have used. Very important is that while we're trying those, we had a lot of trial and errors, and basically the Amish farriers have tried it and basically provided with a feedback, and basically through this feedback we came up with this design where it is coated entirely except for those outer areas, because we need to give some flexibility to the horses, and basically that was the recommendation by the Amish farriers. One important important horseshoe was the composite a horseshoe. This is a composite horseshoe made by a company in Germany, but they had one distributor here in the United States, Dublo, and basically those are a composite material, a composite plastic material with a metal insert, and basically this helps a lot. The metal insert helps a lot in the durability. Very important is that the Amish farriers themselves, some of them have used it, and they said that it is relatively it's not that expensive, and at the same time it has good durability and provides good traction. Um, so we did the first experiment that we have done was really to quantify those to quantify the damage through those quantify the damage, reduction in damage by those alternatives. And the experiment was to use a Marshall hammer, and basically, and as you can see, this Marshall hammer, we have several blows, and we had basically the horseshoe in between an asphalt mixture and the plate, and then we recorded the number of blows and the penetration, and we looked at the damage. And you can see here those that the current horseshoes, we had three different horseshoes that they were basically evaluated, and basically what you can see here is there was a significant damage with with the current calc design, and this is the new design, much less damage. And again, you can see here with the coated as well as with a composite horseshoe, you can see that there is really not much damage that were recorded on penetration. So we looked into two things: the maximum penetration. You can see here with the current design, we looked into current design used by Amish farriers. They have done it. This is something that they are currently using in Holmes and Ware County. Basically, you can see that there is a significant reduction in damage once the new calc design is used. And again, here is much more when you have a coated or a composite horseshoe. The number of blows as well, which is number of blows to failure, and basically you can see how the new calc design as well as the coated can significantly increase that service life of the mix, and basically increasing the number of blows to failure. We also very important thing was in this study is that we wanted to make sure that the horses will not be affected with whatever alternative that we use. So as a result, we looked into basically doing experiments to quantify the effect and impact of those different horseshoes, alternative horseshoes on the horses. The experiment were done by at Louisiana State University at the veterinary school at Louisiana State University, where they have a facility to do the force plate experiments. Um, the horseshoes were dressed uh, by the Amish farriers here and shipped basically to Louisiana State University. And basically, those are the horses that we use. We have five different horses. You can see all those horses. And again, we use five because, from a statistical point of view, we have to do that just to make sure that our results are conclusive. Those are basically the horseshoes that are being evaluated in the experiments. We had four. Again, the new calc design, the coated one, the composite, and basically the current design. Um, those are the horseshoes while dressing those horses, and this is basically pictures at the facility and during the experiments. And I will. This is basically the horse where done different passes, and as we are going with the passes, you'd see there's that plate that measures the forces in the X, Y, and Z, and basically that measures the vertical stresses and all the stresses. And this is basically a typical results that you expect from this. This is while doing, and again, you can see different passes within for the same horse. So one of the most important thing is the vertical stresses. This tells us how much is the stresses impacting the road, as well as it is basically the stresses that are on the joints and the legs of the horses. And you can see that with a new design, new calc design, those stresses are significantly reduced, about 45%. And in the case, there was 89% or more actually, if you're going with a coated or composite shoes. And basically the traction, as you can see, was not really affected by that. A very important thing is that the traction is almost the same for all horseshoe, which means that those alternatives provide a good traction, which is very important for the Amish. So we looked into the cost analysis, evaluating those horseshoes. So we looked into two things: how those horseshoes, how much it will cost the Amish farriers, and also if we're using those horseshoes, how much will be the pavement repairs? So we looked at the two sides of that cost analysis. For the cost of the shoes, or the cost that those the Amish will encounter for using the shoes, we looked into the cost of the shoes themselves, but also we looked into the cost of the horse and expected service life of those horses, because with the different alternatives, based on the analysis that we have and based on basically discussing discussions that we had with the Amish farriers, basically the alternative horseshoes with lower vertical stresses and with a better design will lead to extending the service life of those horses. For example, the new calc design which are used by farriers, two of the farriers said that it will increase the service life of the horses by 50%, and that is something based on their experience. And again, the vertical stress that we did found in those experiments also was in agreement with that. Very important thing is there is that the horseshoes, when you are looking into it, you need also to look into in the cost. We need to look into the cost of how that impacts the cost of the horse, because those horses again are used as a mean of transportation, just like a car for us, and basically we need to look into how much damage those alternative horseshoes or those different horseshoes will be on the horse and the life expectancy of the horses. So you can see here is that when you consider all those factors, the alternative horseshoes can be more cost effective. Actually, they will be more economical. They will have lower price, specifically that one with the lower, with a new calc design with a low profile. And this is basically, it seems to be the best alternative and the most economical. um, Now, when we looked into the cost of the repairs, what we did is we started with, if we have state routes with and without Amish traffic, Amish buggy traffic, we looked into that and the cost that we have, and then basically we looked into trying to evaluate what will be the service life for the different pavements when using the different horseshoes, different alternative horseshoes. And again, we have that. Again, we have seen that the Amish routes have at least 3 times more than the non-Amish routes. So we looked into, with the alternative horseshoes, what we looked into is really, in this case, we looked into predicting what will be the rutting service life for when using different alternative horseshoes. Remember, we had the vertical stress from the experiment, so we used that. We developed a numerical model, a finite element model, basically to determine what will be the vertical strains, and then basically using a transfer functions, we predicted what will be the rutting and the damage that will have for the pavement from the horse when you're using different horseshoes, the different horseshoes evaluated. And basically, when we considered all of that, we have found that basically with the current design, you can see that this is the current design and this is the current cost of the repair annually. You can see that if you're using the new calc design, because the service life will be improved of the repairs, basically you can see that the annual repair cost will be reduced by at least 45% when we have a new calc design, and basically it can be more than that, about 65% when we're using the coated shoes or composite shoes. Um, Very important before I leave this topic, when we presented the results to the Amish, they were again very receptive to the idea of using alternative horseshoes. The only thing that they said is that typically when they are dressing their horses, they are dressing it to the worst case scenario, which is in this case the township roads with a chip seal. There are certain townships that you're using certain types of chip seal, which make it very slippery, the roads very slippery, and basically it becomes too dangerous, and therefore, specifically in hilly areas, they have to use those very high profile to make sure that they have enough traction on those roads. And basically, this is something that we had a discussion with a township during the meeting, and basically that was something that, as we will talk about in the conclusion and recommendation, something that should be worked out, so to ensure that this issue can be resolved and the alternative horseshoes can be used. So the conclusions are in here is that designed airport mixtures that we used for the partial depth repair on Amish buggy routes, they had much better performance than the typical mixtures used. That was based on the lab as well as the field study. The lab tests that were used to evaluate the reduction of the alternative horseshoes, of the damage to the roads when using the alternative horseshoes. They showed that those horseshoes can reduce the damage by at least by about 45% or more. when we're using basically the new calc design, and then basically with the other ones, the damage can almost be eliminated. The experiments that were done at the veterinary school basically showed that the vertical stresses when using those new calc design can reduce the stresses on the pavement as well as on the legs of the horses by about 45% when using those new calc or the horseshoes with a new calc design. If we're using the coated horseshoes or the composite shoes, that reduction in stresses can be more than 89%. Um, Also, those alternative horseshoe have a very similar traction as compared to the ones that are currently being used by the Amish. Um, it, but very important, although those alternatives can be good. One of the main things is that should be resolved is basically the townships that are ship sealed with certain types of ship seal. Those should this issue should be resolved so that the Amish will not have to dress their horses to the worst case scenario, which is in this case will cause a lot of damage to the pavement and basically will not allow to the wide implementation of the alternatives that we have. And basically, in terms of the cost analysis, the new calc design will reduce the cost on the Amish if they are use them by at least 20%, and the ones that are coated and the composite horseshoe basically will reduce the annual cost by 15%. Very important thing is the results also showed that the partial depth repair cost will be reduced significantly when using those alternative horseshoes. It can be reduced by at least 40% if we are using the new calc design, and it can be used more than that, about 60%, if or it can be actually reduced more than that. It can be as such that it will be the same cost as those as the repairs done on roads without any Amish buggies, and basically that can have a significant reduction if we do that. Very important thing is that those alternative horseshoes are economical. The biggest problem that when we discussed is that typically the Amish farriers are dressing their horseshoes to the worst case scenario, and therefore the wide implementation and usage of those alternatives will not be done unless those township roads with certain chip seals basically that issue will be resolved. And basically what we recommended is to start using the new calc design because this is the easiest and most economical, and it can be implemented very quickly. And to make sure that this will be done in the near future, we had a meeting with the Amish farriers, with the township and counties as well. And basically, a task force was formed during that meeting, and basically, it was very important that this task force includes everybody: the Amish representative, Amish community, and then basically the Amish farriers themselves were part of this task force, along with ODOT and the counties and the townships. All are in one task force that will help to resolve the different issues for implementation of the results of this study, and basically to make sure that those alternative horseshoes will be used in the near future. Um, this is basically the recommendation that we have is basically to use those new calc design and basically I mean the horseshoes with a new calc design, and basically that task force should be that was formed during this project will be the one to ensure the implementation of the results in the field. Another important thing is that for the Amish buggy traffic, basically you can see here for the Amish or the roads with the Amish buggy traffic, we have recommended this decision tree for the selection of the mixes. So again, if you're having a low, medium or high Amish buggy traffic, basically this is the procedure that should be used, and that is basically the changes in the process as well as the materials that to be used. Um, so with that, I would like to conclude. One important thing is that the final report will be available very soon on ODOTs and ORL websites, and basically I'm providing links here. Make sure if you're interested to know more details about this interesting project, please make sure to go to those two websites, or one of those two websites actually, and basically you can look at more results and more details about the analysis that was conducted. So one of the questions that we have is whether or not the Amish buggy being pulled have an effect on the stresses, and basically it in general it have, but one of the most important thing that I would say is that really the loads, whether it is the weight of the horse or with the weight of the buggy, it affects of course the damage, but really the main problem is that the area, the contact area is small. So the stresses are very high to start with, even with the horses themselves. Now, having them pulling the buggy, again, this will add into the stress intensity, and basically this will cause more damage, specifically if you're going up the hill, or this will be causing a lot of damage. So it's very important that really the main issue is with the horseshoes and the calks, which causes the contact area to be reduced significantly, and basically the stress intensity will be high even with very small loads. Again, the Amish buggies with more with pulling an Amish buggy, of course the problem will be bigger, but basically really the calcs are the main cause for increasing. So if the calc design increase the contact area, basically this issue will be the stresses will be basically much less. Again, the issue is really with the small contact area there. Thank you.